In this module, you will learn about mechanical and heat energy. Imagine a boy cycling a certain distance. He spends his muscular energy to make the cycle move forward. Similarly, a girl kicking a football spends her muscular energy to make the ball move forward. You may have also seen how an arrow is released from a stretched bow. Here, work is done when the energy stored in the stretched bow is released, which in turn makes the arrow move. In all these examples, we see that some work is done when energy is spent. Do you know that energy exists in various forms like mechanical, electrical, heat, chemical, light? You must remember that energy can neither be created nor destroyed. Instead, it can be transformed from one form to another. It is during this process of energy transfer from one form to the other that work is done. Therefore, we can say that energy is the capacity to do work. Let us now learn about two forms of energy, mechanical and heat. Mechanical energy is a form of energy that gives an object the ability to do work. When the rubber of a catapult with a stone in it is stretched and released, the stone gets displaced from the rubber. Here, work is done as the stone gets displaced. Mechanical energy is defined as the energy possessed by a body by virtue of its state of rest or motion. The energy possessed by a body by virtue of its state of rest is called potential energy. For example, when the bow is stretched, it gains potential energy. On the other hand, the energy possessed by a body by virtue of its state of motion is known as kinetic energy. For example, when the stretched bow is released, the potential energy stored in the bow gets transferred into the arrow and it starts to move. The energy present in the moving arrow is an example of kinetic energy. Thus, kinetic and potential energy together constitute mechanical energy. Let us look at some examples of mechanical energy. Muscular energy in animals is an example of mechanical energy. The moving arms of clock, a rock lying on a high hill, a moving car are all examples of mechanical energy. Let us now look at an example of how mechanical energy can be converted into other forms of energy. In hydroelectric power stations, mechanical energy is converted into electric energy. The reservoir's potential energy is converted into kinetic energy. This in turn rotates the turbines and generates electric energy. Let us now look at heat energy. The energy released when we burn wood, coal, oil, or gas is called heat energy. You must have observed the vent weight, commonly known as the whistle on the top of the pressure cooker, lifts up during a whistle. Let us understand the phenomenon properly. When you cook food in a pressure cooker, the heat energy converts water to steam. The steam in turn lifts the vent weight on the top of the cooker lid and a whistling sound is produced. The lifting of the vent weight suggests that the heat is a form of energy capable of doing work. A young scientist named James Watt studied this phenomenon which led to his invention of the steam engine. In 1765, he invented the steam engine, in which heat energy was used to drive the steam engine. In fact, automobiles utilize heat energy by burning petrol or diesel, which is converted into mechanical energy, enabling them to move. Now let us look at some applications of heat energy. In thermoelectric power stations, the heat energy from burning coal is used to raise steam. The steam rotates the turbines and generates electricity. Thus, heat energy gets converted into electric energy, which is an example of conversion of heat energy to another form. Humans are also dependent on heat energy to do work. The food we consume burns slowly and liberates a chemical named adenosine triphosphate, abbreviated as ATP. ATP breaks down, releasing heat energy, which gets converted into muscular energy, helping us to do muscular work. Thus, we have learnt about mechanical energy and heat energy with examples.